now we take the same denominator, what comment can we make about this transfer function magnitude of this? How will this look qualitatively? At low frequency, at DC, what is the gain? At DC, the gain is 0. All right. So this is magnitude of h is j omega. At DC, it is 0. At infinite frequency, the numerator goes as s, the denominator goes as s square. So what is how does it's 1 over s. So basically, at infinite frequency also the response is 0. At somewhere in the middle, basically you can see it will be it will have, in general we should expect it to have some response which is non-zero at mid frequency, 0 at low at DC, and 0 at high frequency. So this is a band pass response. So what is the magnitude of the response at j omega? At j omega p, magnitude response is 1. What about the angle of the angle of it is 0. Okay. So basically you can see that the gain of the band pass filter is 1. Okay. And you will have a response which kind of does something like this. Okay. So now if you want to find the bandwidth of the band pass filter, what is the bandwidth? The 3 dB bandwidth is defined as the frequency, the width of frequency over which at which the magnitude drops to 1 by root 2 times the peak value. The peak value here happens to be 1. So we need to find, and clearly you can see that there must be 2 frequencies at which the magnitude response drops to 1 by root 2. So now the question is, what are those two? What are those 2 frequencies, right? So to find them, what do we do? Omega over omega p qp, that's the magnitude of the numerator, that divided by 1 minus omega square over omega p square, the whole square. So let's do the square magnitude. So plus omega over omega p qp, the whole square, must be equal to 1 by, think carefully, 1 by 2 squared magnitude. Yes. Now it's just a matter of all right, let's do this over. So omega by omega p whole square, we call this x, then this is x by qp square over 1 minus x whole square plus x over qp square is 1/2. So 2x over qp square must be 1 minus 2x plus x square plus x over qp square. Okay, so this basically means that x square minus 2 plus 1 over qp square times x plus 1 equals 0. Is correct? All right. So what is x now? X is x1 comma 2 are the two roots of this equation, and they are 2 plus 1 over qp square plus minus square root of 2 plus 1 over qp square whole square minus 4 by 2a. So it's basically 1 over 2. So this is nothing but 1 plus 1 over 2 qp square plus minus square root of this becomes we take the 4 inside, the 2 inside becomes 1/4 into 4 plus 1 over qp to the power 4 plus 4 over qp square minus 1. Correct? So that basically means that this this goes away, and consequently we have this becomes 1 and this becomes 4. That's basically 1 over qp square plus 1 over 4 qp to the power 4. This and this is of the form a plus minus square root b whole power 2. So this is nothing but omega over omega p the whole square. Okay. So omega 1, the first frequency at which the magnitude becomes 1 by root 2 is say a minus root b. Correct? And so I mean this will be a minus root b minus a plus root b, and the second frequency will be a plus root b and minus a minus root b. Two of them will be in the for negative omega, because the magnitude response is an even function, and two of them will be in the for the positive one, right? Okay. And so we, if we want, what do we want? We want the 3 dB bandwidth, which is so basically we are looking for, this is omega, at omega p the magnitude is 1, and so this is 1 by root 2, right? So the 1 is a plus root b, okay, and this is a minus root b. Okay. So what is the 3 dB bandwidth? Two root b. So so omega 1 minus omega 2 over omega p must be equal to, oh sorry, this must be times omega p, must be 2 root b. Okay, and you can go and verify. I'll give you the final result. This omega 1 minus omega 2 by omega p turns out to be omega naught over q, omega p over q. Okay. So, so now, so the key point is that the peak value of the band pass filter, I mean the gain of the band pass filter is uh, uh, is 1, and the difference between, I mean, it turns out that the difference between, I mean, this basically is nothing but 1 by q. That difference between the two frequencies at which the magnitude response falls to 1 by root 2 times its value at the peak is turns out to be 1 by q times the 1 by qp times the center frequency. Okay, and it also turns out that as qp becomes larger, I mean as qp becomes larger and larger, what comment can we make about the gain at omega p? It remains the same, right? So, as qp keeps increasing, what happens? The the uh, the characteristic becomes more and more narrow. So, this is increasing qp.